Coming up next this week in computer hardware, let's talk PlayStation 4 780 Ti, AMD's crazy driver update, why 802.11ac won't kill Ethernet, and more. It's all coming up next on Twitch.
Netcasts you love.
From people you trust.
This is Twit.
Bandwidth for Twitch is provided by CacheFly at CACHEFLY.com.
This is Twitch, This Week in Computer Hardware, episode 243, recorded November 14th, 2013. PlayStation 4 and GPU Mayhem.
This episode of This Week in Computer Hardware is brought to you by Ting.com. Ting is a mobile phone service that makes sense. Save money with Ting. Pay for what you use, doesn't require a contract, and offers unlimited devices on one account. To save $25 on your first Ting device, visit twitch.ting.com. That's twitch.ting.com. And by Hulu Plus. Hulu Plus lets you binge on thousands of hit shows anytime, anywhere on your TV, PC, smartphone, or tablet. Visit huluplus.com/twit to start your free 2-week trial. That's huluplus.com/twit.
Welcome to Twitch, This Week in Computer Hardware. I'm the host, Patrick Norton, and the other host is Ryan Shrout. And he is holding, if I'm not mistaken, ladies and gentlemen, in his hands right now, a PlayStation 4 controller. Yes, ladies and gentlemen, this is the all-console, all-the-time edition of This Week in Computer Hardware. I kid.
I was going to say, not even close.
Yeah, no, that's just one of the many things we'll talk about today. It's actually, it's a good week for gaming. PlayStation 4, let's see, it's 6:21 Pacific, so 9:21. So in approximately 2.5 hours, 2 hours and 39 minutes, PlayStation 4 sales. Units get delivered, or if you've been hanging out in front of the local who knows what, you can pick up your PlayStation 4 at midnight. We're excited in no small part because it's the return of the PlayStation to something that resembles a PC architecture. Although, Ryan, you were pointing out to me before the show, the chat room, me, and various long-suffering members of the Twit Cottage technical team, the production staff, those that suffer you and I in our Skype connections, we're talking about the fact that the PlayStation 4 is really architected more like a GPU, while the Xbox One is architected more like a PC. These are big design decisions.
They are. I mean, they're fundamental differences. That kind of the PlayStation 4 with its GDDR5 memory bus and a really large memory, 8 gigs off the side, versus what Microsoft has done with a DDR3 memory interface and a 32 meg cache on the APU. It's just, at the end of the day, like the performance levels they offer are going to be really, really, really similar. But if you look at like raw GPU horsepower, Sony's going to have the advantage, and it's possible, I don't know for sure on this yet, but I believe that the 32 megs of cache that they built onto this chip is meant to facilitate improved context switching, which is like putting the game into sleep mode and immediately going in to watch TV, right? And kind of this ability to flip back and forth. And the Microsoft APU design seems to be more kind of targeted at super low latency, while the PS4 is more targeted at, high bandwidth usage. But they both have their pros and cons. It's just how well these operating systems take advantage of it. I kind of hate that. Sounds like a cop-out in terms of making a decision architecturally one way or the other.
Right.
But at the end of the day, the PS4 has more compute units that matter on the graphics side. So what is Microsoft going to do to make up for that, or off to the side of it to improve, the product offering they have with the TV streaming and the pass-through and all the other stuff that they're trying to do that Sony is kind of ignoring for the time being.
So when we're talking about the GPU on the APU, the thing that the Jaguar cores feed, the video unit, how many cores, how many shader units are we talking about difference between the PlayStation 4 and the Xbox One?
It's not very many. Let me see. Let's see. The devil in the details here. So we're talking about.
Sorry.
Actually, I do want to correct. It was 40. It looks like it's 47 megs of storage on the chip for that 1152. It's so the PS4 has 1152 stream processors, and the Xbox One has 768. So that's actually a pretty sizable difference in shader count. But I knew right here at the end in the last month or two, Microsoft announced that they were increasing the clock speed by like 100 megahertz on their stream processors, their SIMD units, in an attempt to kind of make up for some of that shader difference.
Got it. That's actually, I mean, that's kind of a huge difference. In terms of, if I was buying a GPU right now, what are we talking about in terms of an equivalent GPU to like 800 to 1,000 shaders? I'm going to say it's much lower down on the price range than you might think.
Yeah, I think you're probably looking at like a 270X or 270 at this point. Let's see. I think a 270 has 1,280 stream processors. So a little bit, just like a step under that, which is, all things considered, a pretty high performance part, right? So you're looking at a $200 graphics card, $180 to $200 graphics card for an AMD Radeon R9 270. And considering you're getting that plus the processor plus the storage and the hard drive and in a $400 build on the PlayStation 4, it's actually compelling today as a value add for the amount of compute you get in a small area. Like, one of the things we're going to do this week at PC Per is, can we build a system for $500 that competes against the PS4 and the Xbox One in terms of compute? The secret is, it's really hard to do today. But if you make it $700, then you can absolutely do it, and you can make a much better kind of like gaming horsepower system. But this is kind of what the console's MO has been, right? Is they build great hardware and they sell it at a loss initially, knowing that this is a 8 to 10 year product cycle, and that over those years they'll be able to maybe die shrink, combine more parts. They'll be able to lower costs, and thus they'll eventually kind of break even or even make money on the hardware in the long run. But at first, they want to make sure they've got the best platform they can if they're talking about a 10-year life cycle.
I'm with you on the GPU side of things, especially for 1080p, right? It all falls apart. If 4K becomes like the standard for television inside of 5 years, both of these systems are going to require a major re-architecting, or the televisions are going to have to quadruple the pixels that are coming out of the 1080p game consoles, which actually probably isn't a particularly bad thing, because Blu-ray content looks fantastic on a lot of the 4K monitors. But it's funny when you look at the PlayStation 4 right now, there's not a lot of parts count to reduce. Like, unless they manage to combine all 8 of the memory chips.
Yeah.
Right. I mean, like the power supply is pretty consolidated. The power consumption, I mean, essentially, Jaguar, Kabini, Bobcat, whatever you want to call it. Well, Jaguar, not Bobcat. You're essentially talking about a fast tablet part.
Well, yeah, I mean,
it's the power consumption, but I mean, the power consumption is extremely low, because I was like, oh my goodness, they put the power supply inside I don't know how I feel about the power supply being inside the game console, and thinking about Red Rings of Death and Mayhem. And then I'm like, oh wait, the power supply is in, my projector, my HD TV, the clock radio. And I start listing off things around the house. The 500 watts worth of surround sound amplifier in the closet, the Blu-ray player, the other Blu-ray player, the set-top boxes, and I'm like, okay, the power demands are low enough at this point that it's probably not something to get really worried about. But that's also amazing to realize that the TDP on these parts is so much smaller than they were in the previous generation of consoles. I mean, the goal.
No, I probably wouldn't go that far, because the GPU is much higher performance.
Yeah, I was about to say, because the GPU is probably like it's funny when you realize how much more heat the GPU is pumping out than the actual CPU on the APU, which is a really complicated thing to say, since they're basically an APU, so they are the same part.
Yeah,
you were saying,
definitely different sections of silicon will definitely, be responsible for bigger draws of that power. Cost reductions will come from, this is a 28 nanometer part. They would love for it to be 20 or maybe even 16 nanometer in a couple of years. If they can do that, that's a big cost savings potentially. But then, just the cost of memory will go down. The cost of the hard drives will go down. The cost of the controllers for wireless will go down. And that will be how they will kind of squeeze the dollar out of PlayStation and Xbox hardware in the next handful of years, would be my guess.
This is a good thing. Yeah, no, sorry. It's I got to play with one yesterday and I was like, it's kind of funny. Like I think I was impressed more than anything else with switching things on the menu.
Fair enough.
Launch games, whatever. Oh my goodness, look at how fast I can switch between things. This is amazing. Wow. Should we talk some more about what's going on at AMD since they've been announcing their new lineup of processors? As I reopen the Google Doc that just collapsed on my screen.
So we were talking about the Jaguar cores in the APUs that are in the PS4 and Xbox One. I was actually in San Jose this week for AMD APU 13. It's an event where that's basically a developer conference, but they announced a couple of products. Two of them are these new APUs, Jaguar next generation APUs. So these are called, Bima and Mullins are these new names, and they're replacing Kabini and Tamash. Those are entire SoCs. We're not on. I think we switched the order on you there. So this is the TechSpot story that we had listed there for the visual aid. But Bima and Mullins are based on what's this new line? Puma, right. Which we don't really know much more other than the name of the piece of silicon, right? Or the actual processor core itself. And they're talking about getting 2 times the performance per watt versus what we had in Jaguar today. But we don't know what clock speeds we're talking about. We don't know what they're actually doing to facilitate these changes in performance per watt. Is it simply that they're able to get more clock speed out of the chip, or is it internal IPC improvements that they've done? It's still impressive either way. It was a little disappointing to find out that neither of these new cores actually support the unified memory architecture called HUMA, or HSA, the heterogeneous system architecture that AMD was really strongly pushing at this developer conference. That's kind of like their big deal going forward and how they plan to differentiate. So neither of these parts that are mainly aimed at really low cost notebooks, tablets, that kind of thing. We're talking down, Mullins goes down to about 2 watts, while Bima is like in the 10 to 20 watt range for total SoC power.
Right.
So these are pretty much iterative improvements, it seems, over what we have today. It's just kind of interesting to think about it as like, well, the PlayStation 4 is going to launch tonight with Jaguar cores, and they're already like not the highest end, not the highest. Right. They're already not the most advanced, APU cores in that power envelope as of today, since they were announced. But
well, that's what happens. It takes a while to develop a new console. Yeah. You can only lead the probably 3-year lead on the actual taping out of the part. So AMD can vary fast, but less than expected. Scott Ruth is up for PC Per. Quote, AMD will deliver its latest round of APUs, Kaveri, on January 14th. Built on a 28-nanometer process, will combine the steamroller architecture on the CPU with HSA-compliant graphics core. Next, cores on the GPU. They are expected to bring 856 gigaflops of computational performance. Thomas Ryan at Semi-Accurate, however, remembers that AMD expected over a teraflop. Quote, of course, Kaveri has been a troubled chip for AMD. At this point, Kaveri is over a year late, and most of that delay is due to a series of internal issues at AMD rather than technical problems. But now, with the knowledge that Kaveri missed AMD's internal performance targets by about 20%, it's hard to be very positive about AMD's next big core APU. So, man, meanwhile, that said, if memory serves, here it is. It may have missed their internal targets, but it's still got enough to run the AMD A10 Kaveri APU and image decoder HSA acceleration, which you posted, which I think it's running Battlefield 4, right?
Yeah, Battlefield 4 at 1920 by 1080 at medium quality settings.
Okay.
Which wasn't in like an incredibly demanding part of the game, right, but it was able to get upper 20s, lower 30s frame rates. And this is AMD wanted to point out unoptimized version of the driver for Battlefield 4, and that the Kaveri APU will support Mantle, which is being integrated into Battlefield 4 in December. So that should even give it a little bit more performance increase. At the keynote, they actually showed this same system, which is next generation Kaveri APU against an Intel Core i7 4770K, so the current top end Haswell quad core part, and coupled with a NVIDIA GT 630 discrete GPU. So they gave the Intel system the benefit of a slightly faster discrete graphics card, and they were still, a little bit more than double the performance in Battlefield 4 with Kaveri. So it's impressive to see that they're able to get that kind of performance out of this single chip monolithic, piece of silicon that. I mean, it is disappointing that they kind of fell back on their initial performance claims, and it's obvious that they, even though they will never say it was the case, that they're a little bit late on delivering it, probably because they were trying to get that extra performance in any way they could, right? But in 850, to put it in comparison, the 856 gigaflops of performance that they claimed on Kaveri this week is less than half of the PlayStation 4. Right, the PlayStation 4 is at 1.84 teraflops. So this is at 0.8 teraflops. So these consoles they're launching are still going to be very powerful devices, even in comparison to upcoming parts. But this is going to be cheap. This is going to be widely available. And they say by the end of this year, I'm thinking more CES, just after CES timeframe would be my guess.
And since I'm having a brain spasm, is Kaveri going to be showing up primarily in tablets and combination tablets, like tablet notebooks?
So no, Kaveri is like the replacement for Trinity. Yeah, so this is going to show up in desktop parts first, and then kind of make its way to notebooks. And I think it's making its way to desktops first because to get the higher performance parts that they're quoting, we're going to have to be in higher TDP levels to run at higher clock speeds. So that obviously makes sense. If you start out in the notebook realm, you're going to have to tune everything down, and then performance levels would be even lower than quoted here. So it's a good move both ways for them to start on the desktop side. So this will be like AM or FM2 plus motherboards, I guess, is what these will support. And like I said, I think I would expect we'll have reviews around the CES timeframe. So still an impressive part, despite the fact that it's not as impressive as they wanted us to believe it would be like 18 months ago.
What are we looking at for prices on desktop units or Nook type devices with that processor and with Kaveri in it?
I think this part will be pretty comparable with where we're at today, right? So the A10, what is it, 6800 sells. That's the Richland APU. That sells for, I don't know, what's it? Not loading up for me. I want to say $139, right? Okay. So an A10 6800K. It's the current top end FM2 APU for $139. I expect we'll see in that same range, right? Which now you're talking about getting a pretty high performance GPU and a moderately improved CPU core for $140, $150 in a single processor.
I know. I'm thinking it's like the $500 gaming PC is back, baby.
It is, but see now the issue we have, where we were discussing internally, how do we make this argument, is that we just quoted you 856 gigaflops of performance, which is less than half of the PS4 that is $400. So there's a whole lot different that you get with a PC than a PlayStation 4. Don't get me wrong. I'm not trying to make that argument. But from a pure compute standpoint, what can you do when the game is running? This is not going to bypass consoles today. You're going to have to look at discrete GPUs to get that kind of performance.
We should take a moment to thank our sponsor. Well, one of two sponsors this week, twitch.ting.com. We want to thank Ting for supporting This Week Computer Hardware. If you haven't used Ting, I'm a Ting customer. I pay out of my own pocket. I took advantage of the discount you can get at twitch.ting.com. It's no BS mobile service. Ting is an MVNO. Language is hard. They're a reseller of this nationwide Sprint network. Sprint's network, it holds up quite well, actually. There's no contracts or ETFs. Matter of fact, Ting will actually help if you have an end of term fee, if you have an early termination fee for your existing cell provider because you want to move to Ting because you've looked at the Ting calculator and you've realized how much money you can save by getting off of your contract, and you really should check out the Ting calculator. if you haven't. And you can get to that again up at twitch.ting.com. It's really cool. They will actually give you credit for 25% of your early termination fee, or up to $75 per device if you purchase your device through Ting and port your number. Then send them your final bill with the ATF detailed from your previous carrier. It's pretty cool. Ting.com/ETF for more information on that. But basically, the thing about Ting is you buy your hardware, rather than them saying, we're going to save you so much money. You're just going to pay $100 for this brand new smartphone, and then making it up by making thousands off you in the long run. They're like, hey, buy your phone now, and we're going to charge you the minimal amount per month. It's really, really cool. Each device in the plan costs $6 per month. You can add an unlimited number of devices. Ting breaks your rates out by minutes, text messages, megabytes, and they actually bill you at the end of the month for what you've used. Really cool. No weird line items on your bill. They're not going to make you pay for voicemail or caller ID. You don't pay for tethering. You don't pay for using your phone as a hotspot. You get pretty much all the features with no hidden charges, no recovery fees, no bull stuff. I got to say, the tech support at Twitch has been excellent. I used them once when I was porting a Sprint phone that I had over there. And not only did I talk to a human being that spoke a language I spoke on the phone, but they followed up with an email with basically everything we talked about, the action items, and it was really cool. I have been really impressed by Ting. I'm using them both for a mobile data device and a phone. And I got to say, do us a favor. Support Twitch by going to twitch.ting.com. You can save money, better manage your mobile phone usage for an unlimited number of devices on a single account. You got a big family, Ting can take care of you. You got a small company, Ting can take care of you. And check out their savings calculator. See how much your company can save. By the way, I don't know if I've mentioned this. This week in Computer Hardware viewers get to save $25 on your first Ting device when you sign up. So do us a favor, support the show. Go to twitch.ting.com and start saving today. Oh my goodness! Should we talk about GPUs?
Oh gosh, should we ever? It was funny. Robert was on the show last week, and we talked about GPUs then. Go figure. And I was like, this is something we do every week. It's been that way for like 4 months. I feel like at least. Right. Where there's been new graphics card releases.
Well, it's not the fastest. It's the quietest, but this one's just as fast for half as much money. And this week, AMD's driver update changes the performance and the fan speeds on the R9 290X and the R9 290. What is going on? It's a little early for a driver-based performance boost on the. What's this card been out for? Like 2 weeks?
Well, the R9 290 was only out for like 3 days, maybe 2 days before this happened. So it's kind of a complicated issue. Let me see if I explain it, because I know you missed a week of drama as well.
Sorry.
It's okay. Everybody needs a break from the graphics card drama. I'll get mine eventually.
Dude, I was looking at fast cars and trucks and desert racing stuff and freaking turbochargers and tools. Dude, I got to send you the SEMA pictures. You'll weep. So 3 days after the R9 290 ships, 3 days after your review is posted, you're running more benchmarks?
Well, I have been, yeah. So here's the issue. Tom's Hardware, in their R9 290 review, put out posited a theory that they had acquired a couple of retail cards of the R9 290X, the card that was released a week prior to that, the flagship card, and that the retail card's performance was noticeably lower than the press sample that we got from AMD. And that's a pretty bold statement to make, and it puts a lot of pressure on AMD to kind of prove otherwise. But what happened immediately after that is people started contacting me and said, hey, have you seen these same issues? So we got a retail R9 290 and a retail R9 290X and tested it, and we saw the same performance deltas, or very similar to what Tom's Hardware was referring to. So now we had an interesting dilemma on our hand of figuring out why this was the case, and was AMD at fault? Were they doing this on purpose? So one issue was that we've known since the beginning with this GPU that as it heats up, it slows down. So it's using variable clock speeds, and as the GPU heats up, the fan speed was set to a maximum percentage in order to control noise levels. And then if it couldn't keep it at 95 degrees Celsius or lower at that fan speed, at the clock speed that it was running at, it would lower the clock speed enough and the voltage accordingly to make sure it stayed in 95C at 40% or 47% fan speed, depending on which card you were looking at. So This changed things in that we had to warm up graphics cards now before we could test them, because if you look at some of these graphs on our story, the performance difference between a cold GPU and a hot GPU was noticeable. So we had to account for that, because nobody games for 90 seconds at a time, or if you do, you have other issues. But, so we wanted to obviously facilitate as real world scenarios as we could. So what happens is a lot of the variance we're seeing in performance turns out not to have been caused by silicon differences from chip to chip, but that the fan speeds weren't actually running at fan speeds they were supposed to. For example, on the R9 290 press sample, the one that AMD sent me for testing, when it was set to a 47% fan speed in the driver, the RPM was 2560 or so. All right. But the MSI card that I bought from Newegg at the same percentage, 47%, was only running at 2350 RPM, right? So you're talking about a 200 RPM difference, close to 20% fan speed difference, even though they're both reporting 47%. And what happens is I kind of played around with the percentages, and to almost match the fan RPM speed of the press sample, I had to increase the MSI card up to 50% fan speed. So it was like, okay, what's going on here? Is AMD doing something nefarious? Is this some kind of odd problem with some graphics cards? The next graph down looks at clock speeds, and you can see if you look at the blue line and the red line. So the green line is our press sample. Notice it never comes off of 950 megahertz or so. It's actually 947. The blue line is the MSI card out of the box, and it dips down dramatically into the below 700 in some cases. Once we turned up the fan speed, it got a lot better. Not as good, but a lot better. Right. So what happened is AMD released a new driver that they say makes things how they had always dreamed it was supposed to be. And what they have done now is, instead of prioritizing a percentage of fan speed, they claim that because of variances and the PWMs that they are using on these different boards, that 47% does not equal 47% from card A to B to C. Clearly, we kind of saw that. So now what they're doing is they're targeting an RPM range. So if you look at the second page and you look at the retail versus sample fan speeds graph, you'll see that now the retail and the press sample card are running at the same fan speed without any modifications, but it also happens to be 2650 RPM, 100 RPM higher than even our press sample was running at previously, which makes things even more complicated. Now, so that improves performance, right? It improves performance. It makes the press samples just like the perform just like the retail cards. That's great, right? Except that it also increases our noise. The person that bought that retail MSI card, if it wasn't me, they update their driver to this V9.2, and all of a sudden their fan's running at 300 RPM faster than it was before. That's noticeably louder, noticeably. And they're gonna probably sit there, what the hell happened? Like, I just installed a new driver and now my system is whistling at me all of the time. So the conspiracy theory goes, and this is kind of one that I think I subscribe to, is that AMD didn't really know what they were expecting with all of this. And so this driver change to bump up fan speeds on the R9 290 and R9 290X compensates for their lack of foresight on how much variance there was going to be from GPU to GPU by increasing fan speeds. So what that kind of means is the reviews we did of the R9 290X and the R9 290 are not 100% accurate anymore of what you get when you buy a card and install this version of the driver. And this is what they say it will be going forward. So it's really odd, right? So they have fixed the problem of variance, but they fixed it by making things louder and kind of increasing performance across the board, right? So it's not like cheating, it's just weird. It's just a really odd scenario that they were in and that they put us in and that
why is there
consumers
this much
were in.
variation on the parts? Why didn't you figure this out before you shipped?
Yeah.
Why did you just flatline the fan or firewall the fan? Run the fan at maximum speed from the beginning. I mean, the list of things that you can find a little irritating about this. And it's not necessarily nefarious or evil, but it's just kind of like, you could have sorted this out before you shipped the card. Or maybe it was just until they got into volume that they started noticing this.
Yeah, I mean, like the MSI card, if you look at the sound levels,
right.
It goes from 46 dB to 50. That's pretty big, right?
It's pretty big, but it's not like it went from 46 dB to 70 dB.
No, 46 is already pretty high, to be perfectly clear about it. But 46 to 50 is, 4 dBA at that level is definitely noticeable. So it's odd. I think the worst thing I can say about it, is that AMD seems a little bit incompetent in terms of how they managed everything from the outset. Like we talked about when the 290 launched, that they went from a 40% fan speed, and then they kind of freaked out and moved it all the way up to 47% fan speed 24 hours or 48 hours before launch because they saw the price drops that NVIDIA had. And now they've essentially increased it to 50% in order to make sure that the GPU clock speed variances are low across the board. So that's the worst way to frame it, I think. The best way to frame it is, hey, they found a problem and they fixed it, and they fixed it really quickly. This driver adjustment happened in, a matter of 48, 72 hours. But it's a little confusing as to, as you said, how is this something that your production team isn't seeing, right? If you're making 10,000 cards, surely you test a lot of them and can say, well, how come this one's louder? Or how come this RPM, if you see a 300 RPM difference, which is 20-something%, 22, 23% at that level, that should raise some eyebrows, right? Like that should be, hey, we have an issue.
I mean, it could also be one of those cases where maybe they're doing their testing in a room where there's 50 machines running and you can't really tell the decibel increases.
The decibel increase I get, because that's a pretty scientific study. But if you've got a piece of software on a computer that measure RPM speeds of a GPU fan, you should be able to figure that out. But they didn't immediately. They did now, so it's been addressed. It's just a matter of whether or not you believe they addressed it maybe like too aggressively or too late or anything like that. But
the reality is, the vast majority of the customers are going to they're going to install the cord. It's going to be a vastly improved GPU performance over anything they have if their card is at least a year old. And then eventually they might notice that the fan's a little loud, and then they'll deal with that later.
Yeah. I think you're right. It's the kind of drama in the hardware world we don't need. I especially don't need. I got a lot of stuff to worry about. And all these changes happening last minute. So, well.
Oh my goodness. Overclock 7080 Ti's are here. Thumbs up, thumbs down.
Yeah, pretty impressive. This EVGA one, it's the first one I've gotten in. It has a custom cooler on it. It runs a little bit quieter. It runs cooler. But more impressively, it increases the base clock by 15% over the GTX 780 Ti reference designs. So that's going to equate pretty evenly to performance. So running, we only had time before I left for this last trip to run a couple of benchmarks. But if you look at the graphs, it's anywhere from 8 to 17% faster, depending on the level you look at in the particular benchmark graph. So, hey, that's something we're waiting on from the R9 290s cards. 290, 290X is like these retail samples. They're going to have different coolers, improved noise levels, improved temperatures, and AMD or NVIDIA just had, a partner like EVGA that was kind of ready to go with a new cooling solution out of the box. So they just had that advantage.
OCZ is pushing 19 nanometer flash on the Vector 150. We haven't heard a whole lot from OCZ outside of some of the FURA about what was going on with their business and its stability because the stock price dropped. Alan over at PC Per got in the new Vector 150, and I want to say in 120, 240 gigabyte versions. We really need to look at, if you look a little bit down from that picture, I think the best thing, and if you start reading through the comments on this, is the enthusiast. Keep going. How enthusiastic There's that enthusiastic user up there.
Yeah,
Go back
the
up
icon of go back up a little bit.
It's keep going.
The icon of the guy raising his arms in the air.
That's the one.
Yeah.
Keep going up. Keep going up. There it is.
That's how I sit at my desk every day. It makes it very difficult to type, but I feel like it's necessary to get the point across how excited I am about my
I've
computer.
had my suspicions about you and your excitement issues. So basically, there's OCC's got the workstation category enthusiast and performance. The enthusiast is the Vector, is now moving to the Vector 150. They're claiming basically they're going to ship up to 480 gigabyte drives, 19 nanometer MLC, 550 megabytes per second, sequential read, 530 megabyte per second, sequential writes, random reads, 100K IOPS, random writes, 95K IOPS, and endurance of 50 gigabytes per day for 5 years, which means you're going to have to work really, really hard to wipe this drive out from overwriting it. Alan says it's solidly constructed, increased performance over the prior Vector. And then the primary reason to go in the 19 nanometer flash is they reduce the cost of the flash inside the drive. And quote, the Vector's 7 millimeter thickness allows greater mounting flexibility, and right around $1 a gigabyte, a little bit more for the 120 gigabyte version. So 120 gigabyte, $130, 240, 480 gigabytes for $500. That's $1.04 per gigabyte. That's a good deal. 5-year warranty. Is pretty awesome, and Alan's hoping to see the prices get pushed down on these new OCZ drives because Samsung's doing a good job with pricing, and so are several other companies. So if you've been waiting, if you're looking for an SSD in your stocking, I think this is the Christmas you can start asking for it. At least if you've got $240 or $130 for a 240 or 120 gigabyte drive. Yeah.
It looks like a good SSD. Hopefully, prices seem to have been launched at their MSRP rating. Always, hey, lower would be better. Awesome too. But yeah, if you're missing that boat, if you still don't have an SSD in your rig, you've kind of missed out on the best advancement in enthusiast PCs, I think, in the last couple of years. Any PC, laptops, anything for that matter, I guess I should say. So.
I want to thank Hulu Plus and remind everybody this episode of This Week in Computer Hardware is brought to you by Hulu Plus. Hulu Plus lets you binge on thousands of hit shows anytime, anywhere on your TV, PC, smartphone, or tablet. And if you visit huluplus.com/twit, you can start a free 2-week trial, huluplus.com/twit. So basically, like, Hulu Plus allows you to watch anywhere. It's actually one of the reasons I'm a subscriber to Hulu Plus. Streams HD for the best viewing experience. You can watch your favorite current TV shows like Saturday Night Live, Community, and Family Guy. You can also check out exclusive content, including Hulu originals such as The Awesome, starring SNL, Seth Meyers, and Moon Boy, starring Chris O'Dowd from Bridesmaids. Hulu Plus offers a great selection of acclaimed films and your favorite classic TV shows, and for only $7.99 a month, you can stream as many TV shows and movies as you want, whenever you want. So we want to remind everybody to check out huluplus.com/twit for a free 2-week trial, and that is huluplus.com/twit. And we want to thank Hulu and Hulu Plus for sponsoring this episode of This Week in Computer Hardware.
You know, I was browsing around on the Hulu Plus list today and found that they have all of the episodes of the X-Files.
Oh my goodness. And we lost Brian for a freaking month.
and so I was like, I was watching it, you know, with Hulu Plus, you can stream it on your mobile devices and stuff too. So I was like, oh, this could be dangerous. I don't know. I think there's 9 seasons of the X-Files. And this is back when they made more episodes per season than they do now. It's not like Game of Thrones where there's 10. Now on this, looking at like 15, 16 episodes a year. I'll be here next Thursday, I promise.
Yeah, you need to send.
I won't miss that.
Life to know where to track you down. Hey, you got the EV. It's kind of funny. So NVIDIA ticked off a lot of people by making the Shield in-house. I think it's safe to say. I think I'm comfortable.
Yeah.
Making that statement out loud. So EVGA is making the Tegra Note 7-inch tablet. The NVIDIA has basically got a $200 7-inch tablet built by EVGA. You were holding one in your hot little hands earlier.
I do have it. So it's called the Tegra Note 7. So a couple of months ago, I guess, they announced the Tegra Note platform. And the idea is that NVIDIA was going to start kind of making technically reference design tablets, and then reselling them. And then one of the things they were able to do, or that they wanted to do, or maybe they were pressured to do, was like, hey, we like our partner groups, we like our partner integration. So this is actually, I don't know if you'll be able to see it. Yeah, you can see it on the side. It says EVGA up the top there, right? So this is an EVGA branded tablet, but keep in mind that this is pretty much exclusively developed by NVIDIA. So it's a 7-inch tablet. It's kind of competing against the Nexus 7 in terms of sizing and pricing and those types of features. It's got as you would expect, a Tegra processor in it. It's a Tegra 4 in this case, so it's running fairly high performance on the CPU and GPU side. So great for any kind of applications like games that you're using that require a lot of performance. It's definitely faster on the SoC side than the Nexus 7. And it's almost as fast as the NVIDIA's Shield device. I think it runs at like 100 megahertz lower clock speed. The screen is nice. It does have it's a 1280 by 800 screen, so it loses in that battle to the Nexus 7, but it does have a stylus. And you saw the picture up there of my wonderful artistic skills. And here's some more that's kind of getting washed out there.
It's a cat, right? Or a shmoo?
Yeah, we'll go with all of those things. So it's a passive stylus. It's not an active stylus. And so that means there's going to be some differences in terms of super, super precise drawing. Like doing things like dots is much easier on an active setup than this. But it does pretty well in terms of, you can see here, you can draw thin lines or you can draw thick lines. It's pretty good for, again, this is a $199 tablet, which puts it $30 less than the cheapest Nexus 7. So it's a little bit bigger. It's a little bit heavier, not very much. It has front-facing stereo speakers that I really, really like. They sound great. And I don't know about anybody else, but I'm always annoyed by how no phone, other than I think the HTC One, right? It has front-facing speakers, but if you watch a video on a tablet, you're watching it with the screen facing you, right? And so having the speakers point in the exact opposite direction of your face is probably the wrong design cue, right? So this just makes sense. Obviously, you have to size the bezel differently because of it, and that's one of the reasons why a lot of people don't. They want to make sure it's pretty, and maybe sometimes at the expense of actual function. But like I said, it's got a 1280 by 800 screen. It's not the best screen I've ever seen, but it's pretty good for what it is at $199. The gaming on it is pretty high performance. It's got this smart cover-ish type thing as well that you can use as creates it, so now you can put it on a stand and it's got a couple different angles and that kind of stuff. So it's a pretty nice tablet. I think the battle between this and the Nexus 7 at this price point is much more competitive than I thought it was going to be. I'd probably maybe still lean towards the Nexus 7. It's just, it kind of like, it just has the feeling of being a higher quality device, even if there's nothing that this is doing wrong in that instance. But, if you like the idea of front-facing speakers, if you like the idea of, the extra performance of the Tegra 4 SoC for gaming, it might make sense to go this route. It also, the stylus is a big plus. And then this is stock Android, which is nice. The Nexus 7 obviously is as well. But this is currently on 4.2.2, but they said they'll have 4.3 available by holidays. So depending on which holiday they're referring to, that could be very soon or it could be next month. So either way, still pretty good. So it's pretty cool. I didn't know what to expect really at all going into it, but I ended up coming away thinking, yeah, I could recommend that to people and not feel like it's a bad decision at all. I think it's actually pretty well built and it has a pretty good feature set for, again, sub $200.
Ladies and gentlemen,
you remember it wasn't that long ago. Sorry, it wasn't that long ago that like a sub $200 tablet was like a piece of garbage, right? Something you could only find at Kmart that was from some manufacturer you'd never heard of. Yeah, right. And I remember, we got to run over to Kmart's in our local areas and see if they have this whatever brand it was. And now that you can get top of the line hardware, good design for $199 is pretty cool.
What's frightening is you can get a decent screen for $199 because that used to be the thing that's really setting apart a $7,500 tablet from a $200 or $300 tablet, or $500 tablet was the quality of the screen. The processing was much closer. And now you look at some of the screens on the $200 tablets, you're like, really? That's pretty freaking awesome, people. We have a fun question from Jim Jam in the chat room. He says, best graphics card for less than $100.
Oh, man.
You even had your hands, on a graphics card that expensive in recent times?
It's been a while, to be perfectly honest, because all of these guys have been launching new high-end cards. How much? So I really do like the R7 260X. How much is that? $139? That's close enough, right? The one thing I'll say about the R7 260X is AMD kind of announced the updated bundling program, and the R7 260X gets 2 games, and one of them can be Thief. That isn't even out yet. The new game, I think it comes out in February. So that's easily a $50, $60 PC gaming title. It's going to be a really good one, I think, based on what I've seen. So that kind of cuts the price of that graphics card by that much. Plus, you can pick up another title from that list if you haven't played it as well. Once you get under that, I'd have to say the how much is just the base GTX 650 now? You can get it for $101.99 after rebate. That's really close to $100. I see a couple of them for $99.90 after rebate. So the GeForce GTX 650 1 GB graphics card is like $109 MSRP now. That's a really good card as well. But I would personally, if you can, splurge for a little bit and get that $139 option. Once you get below that, it gets really even below $150. It gets really, really crowded in terms of competition from AMD and NVIDIA, and so it's easy to make the right choice, I guess is how I'll say it, because there's not a whole lot of performance variance under there. It gets really, really small. So things like bundles, game bundles, can actually make a difference if you're buying it for gaming. If you're not buying it for gaming, then totally different debate. But I would say that right now my caveat would be is I haven't looked at the sub $100 graphics card market in say 4 to 6 months with any kind of really critical eye, and that'll be coming up here as AMD kind of releases some of the new R7 series that's a little bit less expensive. So we'll have to reevaluate things down that low fairly soon.
Oops. As I refresh my screen, Zephyr says, Ryan Strout, okay, my question is 802.11ac going to become the standard worth ditching your cables for? No. 802.11a, like 802.11ac is really cool. But to hit like the gigabit speed, it's not gigabit speed. The clients are only required to support us. The clients only need to have 1 data stream, which means they can hit like the theoretical maximum could be 433 megabits per second. You need 3 streams to hit the 1.3 gigabit per second theoretical maximum, which you're not going to hit outside of a laboratory. And we can also argue that Ethernet doesn't hit its theoretical maximum, but yes, 802.11ac can deliver or should deliver data rates up to double. You should be able to like double 802.11n compared to 802.11ac. But it's only 5 gigahertz, which I think is going to give it range issues, even though sort of the beam forming should get around that. 802.11ac will support older devices, but the reality is man, speed isn't the reason I've got gigabit running to most of the devices in my house. I run, copper to most of the devices in my house because then I don't have any issue with the fact that there are 17 Wi-Fi networks, within 25 yards of my house, maybe 40 yards of my house. And if I go to 100 yards of my house, there's probably 100 Wi-Fi networks or more. And I live in a small city. We're not particularly high density. I've lived in high density neighborhoods where, I was in a buddy's apartment and we could detect 175 Wi-Fi networks. It sounds ridiculous, right? You're laughing, but a typical you get into a typical suburban neighborhood with a quarter acre per house, and you can probably, if you've got any kind of sensitivity on the laptop or device you're using to search for Wi-Fi or search Wi-Fi, scan the Wi-Fi bandwidth, you're probably going to pick up, 25, 50 different Wi-Fi routers. And the reason I'm hammering on that fact is basically in the United States, we have a very limited amount of bandwidth that you're free to screw around with. 2.4 gigahertz being kind of the most famous, 5 gigahertz being the other one. We can talk about 900 megahertz, but most stuff we see is like 2.4 or 5 gigahertz in the computing world. And everything is on 2.4 gigahertz. Wireless phones, microwave ovens, Wi-Fi, anything anybody invents in the near future, RC-controlled cars, remote controls for garage doors. So it's messy and it's crowded. And 5 gigahertz, I think, is going to be that way in the none too distant future. So I think for a lot of people who want the best performance and the least amount of reliability issues, just getting, just yanking cables around the house is the optimal solution. Not that I say solution that often. Is 802.11ac going to be fast? Yeah, if your client supports multiple, 3 streams simultaneously, and you've got a router that can support more than 8 or 10 streams, because there's nothing more pathetic than having like 5 clients that can support, a gigabit, but not having a router that can support all of the clients at the maximum speed simultaneously. It's early. I don't feel like 802.11n was as successful as it should have been, but that also
I agree with that. Yeah.
It would be interesting to talk to some of the manufacturers to see, if they have any actual idea of what people are using in the real world. I turned off 5 gigahertz in my house, and I don't live in a particularly big house. There's stucco on the outside of my house, but there's no, there's the horsehair plaster in the walls is enough to just wipe out 5 gigahertz performance in my house. My house isn't that big. It's 1,100 square foot Craftsman, maybe 1,200 if you count the
just dense walls.
Yeah.
Will do that. Yeah.
So, that said, there's a lot of things you can do to improve performance. A lot of really simple stuff can make a huge difference. And I think the things I would do before upgrading, to 802.11ac would be like, changing the location of the router in my house, building an inexpensive, aluminum foil and paper reflector to go behind it, checking different channels to see the performance through it on that, making sure you actually have all the settings correct. And I'm not trying to be a jerk when I say this, but there's a lot of obscure settings inside of most routers. Every freaking router company has a different name for half of the same features.
This is true.
And there's a lot of router companies out there. There's at least 2 that will remain nameless at the moment that I will never buy from again because I bought a product and they never issued a single update, or maybe they issued one update for it like 6 months or a year later, and then they abandoned the product. There's anger here.
I sense that a little.
Well,
okay.
when you go,
we all get burned
when you go
sometimes.
through like, when you go through like $250 worth of routers or $300 worth of routers in like 9 months, you tend to get a little cranky about it. One one had been, it's irritating. We've done a bunch of stuff on Texilla about using some of the open source router softwares, and they can actually do a lot to make a router more rational its behavior. And I gotta say, there's some freaking $40 routers now that are fantastic in performance. And one last thing before I end this ridiculously overlong rat, and I'm afraid to look in the chat room to see what they might be saying, is smallnetbuilder.com is phenomenal for wireless reviews. And if he says it's going to replace 802.11ac, he's probably right. But 802.11ac,
listen to him rather than us.
Yeah, rage quit, says Fushigi in the chat room. It's networks, man. They're hard. And wireless networks are harder. Chimera says, Ryan previously said to ignore the 290X in light of the 290. With all the 290 drama, does he stand by that recommendation? Is the 290 still the best bet in that price range?
Yeah, I think so. I think at $399, it offers very similar performance to the $549 R9 290X. So that alone makes it it's not the best card, but it's the best value card for sure. If what you care about is performance for your dollar, the R9 290 is probably still the best card out there. Because the GTX 780 Ti is from NVIDIA, that's $100 more expensive than the R9 290, and it gets beat most of the time by the AMD card as well. The disadvantages of the R9 290 are that it is loud. It's the loudest of the video cards we've tested to date, because they have continued to increase the fan speed. The R9, keep in mind, the R9 290X and the 290 are the same PCB, the same silicon. Just they've tweaked the shader count a little bit and the clock speed some, but the fan speed of the R9 290 is now 2,650 RPM, while it's 2,200 RPM on the 290X. So now you're talking about a 450 RPM difference on the exact same cooler for reference designs. So it's going to be louder, but it's going to perform pretty close. I'd say within 5%. Maybe 6, 7, 8% for $150 less. So it's hard to argue with that logic if you are an enthusiast gamer that is not really noise conscious.
Noise conscious gamers. That seems to be a theme of today's episode. Not noise conscious. Web 8475 says, Patrick Ryan, is it better for 4K, a R9 290 water cooled, or a reference 780 Ti? And can a 780 Ti do 3x 4K like the Radeon cards can?
Oh man, yeah, they will be able to do.
I like it when you actually.
Why are you buying $9,000 worth of monitors? Is my first question. That's
because he can.
Serious
Ryan,
investment.
because he can. Or he could be buying actually, we should put this into context. Web 8475 of the chat room. You are not going to buy 3 inexpensive 4K monitors this year and game on them. Okay.
He's saying 3 4K monitors with 4 780 Ti's in SLI or 4 R9 290s in Crossfire.
It does kind of boggle the mind. I think this is an aspirational purchase. But okay, so step one, a 780 Ti will feed a 4K. The problem is that a 4K monitor you can buy right now, except for the $3,500 Asus monitor that Ryan may or may not have shipped back to Asus when they pry his cold, dead fingers from around it. He's in love with that. It's a 32-inch 4K monitor. It's ridiculous. It's awesome. It's a sack of just excellence. But if you're looking at a $1,500 to $5,000 to $8,500 to $10,000-$15,000 4K monitor, almost all of them are running at 30 hertz, and gaming sucks at 30 hertz on 4K.
Yeah, the 4K TVs are not a good option for gaming. Yeah. The 4K monitors, if you get the tile displays, they're great options for gaming as long as you have the money to support them. Because you're not just buying a $3,500 monitor, you're buying $1,000 or $2,000 worth of graphics cards to make sure that you can run on that monitor. If I had to pick today, I would go with SLI over Crossfire, simply because of the remnant issues with AMD Crossfire. So they are fixing them. They are getting better, but it's not as good as what NVIDIA is doing. And especially when you get past 2 GPUs into 3 GPUs, I think NVIDIA's SLI configuration is going to be better than what Crossfire is like, even with the new XDMA interface or Crossfire version with 3 GPUs. So if somebody said, hey Ryan, here's all the money and build out the system, I would get 3 4K monitors and I would probably get 3 GTX 780 Ti's. Not 4 because I'm not crazy, just 3.
Just 3.
That's kind of the way I would go. But I have access to more hardware than most people do, and I still don't have a setup like that. I'll have to look around the office. Let me see what I got.
Oh my goodness. PlayStation 4 launched tonight. I got to go hang out with Rev3 Games guys. I get to talk about hardware, and it's the PlayStation 4 is all games, and unless you want to run Netflix or Amazon Prime, no media PC love.
Yep, it's not trying to be more than what it is, I guess I'll say.
Well, it's trying to be the is of what it is.
All right, that's a good way to put it.
Yeah, that was almost a sentence. Oh my goodness. But I want to thank everybody for hanging out with us tonight, especially the chat room. Email us, Twitch, TWICH at twit.tv. You can find us on Twitter at Ryan Trout, at Patrick Norton. And I suspect there are more graphics card related things coming from your life of testing and mayhem in Kentucky at PCPro.com. Would I be wrong?
No. You would not be wrong at all. Not at all.
Oh my goodness. Ladies and gentlemen, if you're unpacking a PlayStation 4 as we speak, you're going to need to upgrade it before you run Blu-ray, and none of your freaking home theater accessories will work with it. Well, if you have a universal remote type Bluetooth adapter, or a PlayStation 3 Bluetooth remote. But that menu is fast.
I'm looking forward to it. Now I'm really excited about the menu.
All I'm going to say is the best part, like my two favorite things outside of like one of the games I was playing is there's like menus and browsing. It'll be too late if you're listening to this after the fact. You won't be able to join us live, but we're going to do a live teardown of a PS4 on PC Perspective tonight as well. So that'll be 12:30 a.m. Eastern time, maybe. Depends on whenever I get back from Best Buy with my PS4, and hopefully I don't break it all. Good luck, sir.
Thank you.
Good luck. That's it for this episode of Twitch This Week in Computer Hardware. I'm Patrick Norton.
I'm Ryan Trout.
We'll see you next week on Twitch.